In the next few examples, I'll show you how the loop trick can be used to find logs. Keep in mind that if you ever have a log, you are actually trying to find the value, so I'm always just going to say equals x. Remember, if there's no base here, technically it's a base of 10. So what we're saying here is, using the loop trick, 10 to the power of x is equal to 10. Or that's basically 10 to the first. So what does that mean? That x is 1. Our value is 1. Again, doing the loop trick, if this is equal to x, if we say 5 to the power of x is equal to 0.2. What is 0.2 the same as? 0.2 is technically the same as 2 over 10, or I guess we can rewrite that as 1 over 5. Oh, 1 over 5, using laws of exponents, is the same as saying 5 to the negative first power. So therefore, this value is negative 1. Using the loop trick here, we say 8 to the x is equal to 2. If 8 to the x is equal to 2, we know that 8 is 2 to the third power. So what we now have is 2 to the 3x equals 2, and technically that's to the first power. So what we know is that 3x equals 1. So x equals 1/3. Let's go on to the next page. Number 7. Again, let's do the loop trick here. We can say 5 to the second power is equal to x. So x is 25. Number 8a, let's do the loop trick. What we're saying here is x squared equals 121. In solving for x, remember, whenever you take the square root on both sides of an equation, you always need plus minus. So now we get that x is equal to 11 and negative 11. Now, one interesting thing about number 8 here is, remember that the base value cannot be negative. Base cannot be negative. And for that reason, we actually take out the negative 11. We only have the answer of 11 in this case. Okay. Number 9a, let's take a look at that one. So again, I'm going to make it equal to x, so that way I can do the loop trick. 6 to the x is equal to 6 square root of 6. Like that. What does this really mean? Well, this is 6 to the x is equal to, this is like 6 to the first power times 6 to the half power. And then if I'm multiplying numbers with the same base, I know that I can add those exponents.
Let me help you carry your bag.
Okay, thank you. Okay, so now we have 6 to the x equals 6 to the power of 1 plus half, or that's the same thing as 1 1/2. So we see that x is equal to 1 1/2. Okay. Number 10. This one we're not allowed to use a calculator, but what we do see is that log of 6.92 is about equal to 0.8401. What does that mean? Well, if we have a base 10, technically it's the same thing as saying 10 to the power of 0.8401 is equal to 6.92. That's just something very helpful to keep in mind as we're solving the next 3 situations. Log of 69.2, if I make that equal to x, then what I'm saying here is 10 to the x is equal to 69.2. Now, since I'm working with base 10 here, I can tend to think of 69.2 as the same thing as 6.92 times 10. The reason why I'm thinking of 6.92 is because I saw that 6.92 occurred earlier. I want to somehow turn that 6.92 into something else. And there it is. 6.92 is the same as 10 to the power of 0.8401. And then we're multiplying that by the 10 that we see there. Okay. So now we have 10 to the power of x is equal to, what do we do with these exponents? We can add them up. So we have 10 to the power of 1 plus, or 1.8401, and that actually just kind of shows us what our answer is, that x is equal to 1.8401, like that.